So in today's class, we will cover inverse trigonometric functions synopsis. Okay, so as you know, sine theta, cos theta, tan theta, these all are trigonometric functions. But what are inverse trigonometric functions? Sine inverse theta, cos inverse theta, tan inverse theta, cosec inverse theta, secant inverse theta, cot inverse theta. These are the 6 inverse trigonometric functions. Now let us see some identities and some formulas related to inverse trigonometric functions. So take the first formula. In that, the first bit is sine inverse of sine theta is theta. If theta lies between closed interval minus pi by 2 comma pi by 2. Closed interval means you have square brackets, and closed interval or square brackets means these corners are included, which means minus pi by 2 and pi by 2 is included. Now the second formula is sine of sine inverse x is equal to x if x belongs to closed interval minus 1 comma 1. So square brackets are closed interval and open interval is simple brackets. So whenever simple brackets are given, the corners are not included, and whenever square brackets are given, the corners are included. Now the second formula is cos inverse of cos theta equals theta if theta belongs to closed interval 0 to pi. So whenever theta is in between 0 and pi, including 0 and pi, then in that case you can write cos inverse of cos theta as theta. Then second bit is cos of cos inverse x is equal to x if x belongs to minus 1 comma 1. So cos of cos inverse x will become x if x lies in between minus 1 and 1, and cos inverse of cos x will become x if x lies in between 0 and pi. Pi is 180. Then the third formula is tan inverse of tan theta equals to theta if x belongs to minus pi to pi by 2. Which means if the angle is in between minus 90 and plus 90, then tan inverse of tan theta becomes theta. Theta and x both are one and the same. There is not much difference between them. So then tan of tan inverse x equals x if x belongs to R. Next, number 4. Cot inverse of cot theta equals to theta if theta belongs to open interval 0 comma 5. So here the angle lies between 0 and pi, excluding 0 and pi. So 0 and pi is not included here. Please note this. Okay. So here simple bracket means open interval. Open interval means the corners are excluded. This is the first bit, and the second bit is cot of cot inverse x equals x if x belongs to R. Next, number 5. Sine inverse of minus x equals minus sine inverse x if x belongs to closed interval minus 1 comma 1. And the second formula is cos inverse of minus x equals minus cos inverse x if x belongs to the same interval minus 1 comma 1. Number 3. Tan inverse of minus x equals to minus tan inverse x if x belongs to R. Number 4 is cot inverse of minus x equals x minus cot inverse x if x belongs to R. So for all real numbers, tan inverse and cot inverse is the same. But sine inverse and cos inverse will be minus sine inverse and minus cos inverse only if x lies between minus 1 and plus 1, including minus 1 and plus 1. Next, number 6. Now I am going to start the identities. So sine inverse x plus cos inverse x equals to pi by 2 if x belongs to closed interval minus 1 comma 1. And number 2 is tan inverse x plus cot inverse x equals to pi by 2 for any x belongs to R. Number 3, secant inverse x plus cosecant inverse x is equal to pi by 2 if x belongs to minus infinity comma minus 1 union 1 comma infinity. So what does it mean? This is the interval when x does not lie between minus 1 and plus 1. X is less than minus 1 and x is greater than 1. So this representation means x does not lie between minus 1 and plus 1. Next, number 7. Sine inverse x can plus or sine inverse x can be written as cosecant inverse of 1 by x for x belongs to minus 1 comma 0 union 0 comma 1. So this is excluding 0. So it takes all values from minus 1 and 0 excluding 0. And again it takes values from 0 to 1 excluding 0. So here only 0 is excluded. Remaining all numbers are included between minus 1 and plus 1. Then number 2 is cos inverse x is equal to secant inverse of 1 by x for same interval x belongs to closed interval minus 1 comma 0 union 0 comma 1. 1 and minus 1 is included, 0 is excluded. Then number 3, cot inverse x can be written as tan inverse 1 by x if x is positive. Number 4 is cot inverse x can be written as pi plus tan inverse 1 by x if x is negative. So if x is negative, it is number 4, and if x is positive, it is number 3. Now next, number 8. Sine inverse x plus sine inverse y equals sine inverse x root 1 minus y square plus y root 1 minus x square if x comma y belongs to closed interval 0 comma 1, and there is one more condition, x square plus y square is less than or equal to 1. Next, number 2. Sine inverse x plus sine inverse y equals to pi minus sine inverse of x root 1 minus y square plus y root 1 minus x square if x comma y belongs to 0 comma 1 and x square plus y square is greater than 1. So if x square plus y square is greater than 1, then it is formula number 2. And if x square plus y square is less than or equal to 1, then we take formula number 1. Number 9, sine inverse x minus sine inverse y equals to sine inverse of x root over 1 minus y square minus y root over 1 minus x square if x comma y belongs to 0 comma 1. Next, number 10. Again here you have two conditions. Cos inverse x plus cos inverse y is equal to cos inverse xy minus root over 1 minus x square root over 1 minus y square if x comma y belongs to closed interval 0 comma 1. And the other formula is cos inverse x minus cos inverse y equals to cos inverse xy plus root over 1 minus x square root over 1 minus y square if 0 less than or equal to x less than or equal to y less than or equal to 1. Next, number 11. Tan inverse x plus tan inverse y. This is tan inverse of x plus y by 1 minus xy if xy is less than 1. This is one formula for tan inverse x plus tan inverse y. Then we have another formula, pi plus tan inverse of x plus y by 1 minus xy if xy is greater than 1, x is positive, y is positive. Then you have one more formula. It is minus pi plus tan inverse of x plus y by 1 minus xy. If xy is greater than 1, x is negative, y is negative. And then you have one more formula. It is pi by 2 if xy is equal to 1. So first you need to check the condition x into y. If it is equal to 1, then fourth formula. If it is if it is greater than 1 and x and y are negative, then third formula. And if xy is greater than 1 and x and y are positive, then it is second formula. And if xy is less than 1, then it is first formula. Next, number 12. Tan inverse x minus tan inverse y equals tan inverse x minus y by 1 plus xy if x is positive, y is positive, or x is negative, y is negative. So for tan inverse x minus tan inverse y, you have only one formula. Then number 13. 2 sine inverse x can be written as sine inverse of 2x root over 1 minus x square. Then 2 cos inverse x is equal to cos inverse of 2x square minus 1. Number 3, 2 tan inverse x equals tan inverse of 2x by 1 minus x square. Then number 14. In that again you have three conditions or three formulae. 3 sine inverse x equals sine inverse of 3x minus 4x cube. Then number 2, 3 cos inverse x equals cos inverse of 4x cube minus 3x. Then number 3, 3 tan inverse x equals tan inverse of 3x minus x cube by 1 minus 3x square. So with this we are done with the concepts.